Ever wonder how the next generation of ships will glide silently through the water, leaving zero emissions in their wake? Forget giant propellers and noisy engines. Today, we're diving deep into the revolutionary world of electric pod drives, the sleek, efficient powerhouses that are changing marine propulsion forever. For over a century, most ships have relied on large diesel engines connected to long shafts and bulky propellers. They get the job done, but at a cost. These systems create intense noise and vibration, they're mechanically complex, and they burn fossil fuels that pump greenhouse gases and pollutants into the air. As global shipping grows, these drawbacks are becoming harder to ignore. Traditional shaftline systems also take up huge amounts of internal space, limit how efficiently a ship can be designed, and reduce maneuverability. Turning a large vessel in tight harbors or in rough seas is challenging, and every extra degree of inefficiency means more fuel burned and more emissions released. Now imagine pushing all that mechanical complexity outside the hull into one compact, streamlined unit. That's the idea behind electric pod drives. These are self-contained propulsion systems where the electric motor and propeller sit together in a pod beneath the ship, connected by a streamlined mounting strut. By moving the motor outside the hull, pod drives free up interior space, reduce mechanical losses, and allow naval architects to design more hydrodynamic hulls. The result is a compact, external powerhouse that delivers thrust more efficiently and much more quietly than traditional propeller shaft systems. So, how do electric pod drives actually work? Power starts with a source on board the ship. This could be a diesel generator, a battery bank, a fuel cell, or a hybrid system. That electrical energy travels through cables down the mounting strut into the pod, where it drives a high-efficiency electric motor. The motor turns a propeller, which pushes the ship forward, backward, or even sideways depending on how the pod is angled. Unlike mechanical shaft lines full of rotating parts, gearboxes, and alignment challenges, electric pods rely on simple power cables and a compact motor. Fewer moving parts means less mechanical loss, lower maintenance demands, and a cleaner, more direct path from energy source to propulsion. Where electric pod drives truly shine is in maneuverability. Because the entire pod can rotate 360 degrees, thrust can be directed in any direction. That allows a ship to move sideways, pivot on the spot, and respond instantly to commands, a huge advantage in tight harbors, narrow channels, and offshore operations. Modern pod-driven vessels can use this precise thrust control for dynamic positioning, automatically holding a fixed position and heading despite wind, waves, and currents. In ports, pods make docking smoother and safer, reducing the need for tugs and allowing captains to position large ships with surgical precision. Because the motor is electric and the pod is streamlined, these systems generate much less vibration and underwater noise than traditional propellers driven by large diesel engines. That means quieter ships and quieter oceans, an important benefit for marine life that relies on sound to communicate, navigate, and hunt. Pair pod drives with clean power sources like large battery banks, short-charged at green ports or hydrogen fuel cells, and you get a pathway toward fully zero-emission operation. The more efficiently you use the energy on board, the fewer resources you need, and the closer the ship gets to leaving no carbon footprint at all. Electric pod drives typically deliver better fuel efficiency than conventional shaft systems, especially on vessels that operate at variable speeds or need frequent maneuvering. Over a ship's lifetime, that efficiency can translate into significant fuel savings, lower operating costs, and reduced emissions, benefits that appeal to both ship owners and regulators. With fewer large rotating components and simplified mechanical layouts, pod-driven ships can enjoy lower maintenance demands and improved reliability over time. When you factor in fuel savings, reduced downtime, and the ability to meet stricter emissions regulations, the total life cycle cost of pod systems often becomes highly competitive with traditional propulsion. This isn't science fiction. Many of today's largest cruise ships already rely on electric pod drives. They gain smoother handling, reduced vibration for passengers, and better fuel economy on long voyages, all while cutting emissions compared to older propulsion setups. Electric pod drives are also popular on ferries, which need fast, precise maneuvering and frequent docking, and on offshore support vessels, where dynamic positioning is critical for safe operations. In each case, pods provide the right mix of control, efficiency, and comfort. Looking ahead, pod drive technology is set to become even smarter and cleaner. Advanced control systems will fine-tune thrust in real time, integrating weather data, traffic information, and energy management to squeeze out every bit of efficiency from each voyage. At the same time, pods will integrate more closely with renewable energy and hybrid systems, enabling ships to run on a mix of batteries, green fuels, and even shore power. As autonomous and remotely operated vessels become more common, the precise, computer-friendly control of electric pods will be a key enabler. Step back and imagine tomorrow's fleets. Quieter ships, cleaner wakes, and precision maneuvering built into every voyage. Electric pod drives are at the heart of that vision, reshaping how we move people and cargo across the world's oceans. So when you see a ship gliding almost silently across the water, with barely a ripple and no visible exhaust, you might just be looking at the impact of electric pod drives. By moving propulsion outside the hull and embracing clean, efficient electric power, we're witnessing a fundamental shift in marine technology and a powerful step toward truly sustainable oceans.